Very good morning, students. This is the second problem we are solving in oral transients. These type of problems are very important. Here the switches in this problem, switch is having two position 1 and position 2. So in this type of problem there can be two category. In switch position, the switch is in position 1. No, it can be either kept at long time. Okay, either kept at long time or some, it can be after the switch is moved to position 2 after 1 millisecond, or one time constant. What is time constant? Tau is equal to L by R. We have to calculate the value time. Okay, one time constant or 5 millisecond, like that it can be asked. Okay, so in this case we are facing this one. After 1 millisecond the switch is moved to position 2. So we are going to solve for this one. If it is kept for long time means the inductive effect is cancelled. It acts as a short circuit. So simply we will get initial current. Correct? So ரொம்ப நேரம் இருக்குது அப்படின்னா இந்த இண்டக்டர் வந்து ஒரு ஷார்ட் ஆக்ட் ஆகும். அப்போ வந்து இனிஷியல் கரண்ட் வந்து V/R அப்படி கிடைக்கும். ஆஃப்டர் 1 millisecond இல்லை after one time constant இந்த மாதிரி கொடுத்துருந்தா we have to find out a transient current when the switch is in position 1. Then we have to substitute 1 millisecond. இப்போ போன வீடியோவில் நம்ம ஒரு ப்ராப்ளம் பார்த்தோம் இல்லையா, வாட் இஸ் த கரண்ட் ஆஃப்டர் 0.5 செகண்ட் 1 செகண்ட் பார்த்தோம் இல்லையா, அந்த மாதிரி. ஸோ ஸ்விட்ச் வந்து பொசிஷன் 1ல் இருக்குதுன்னா ஒரு டிரான்சியன்ட் கரண்ட் ஈக்குவேஷனை ஃபார்ம் பண்ணிவிட்டு அதில் அந்த டைமை சப்ஸ்டியூட் பண்ணணும். ஸோ we are facing now this type of problems. Some after 1 millisecond, sometime after 1 millisecond. Correct? See the question for the circuit shown in figure with the zero inductor current. The switch is closed on to position S1. So S1ல இருக்கும்போது அதுக்கு initial current வந்து 0. Correct? At 1 millisecond it is moved to position 2. So ரொம்ப நேரம் இல்லாமல் 1 millisecondலேயே மூவ் ஆகிறதுனால we have to form transient current equation for the switch in position 1 as well as the switch in position 2. So ரெண்டுத்துக்குமே ஈக்குவேஷன் எழுதணும். Okay, so we have to compute voltage across the inductor in both the intervals and sketch the waveform of VL. This is a question. Okay, so first வந்து as I said earlier, to find out current. Correct? What are the 4 steps I told already? First one, you have to write KVL equation. Second one, we have to find out Laplace transform for that one. Third one, take the partial fraction. Fourth case, take inverse Laplace transform. Correct? For any transient circuit you have to follow these 4 steps. Okay, so first case, okay, switch is when switch is in position 1. Okay, then we'll have E1 source which is in series with R and L. Correct? So you have to write equation, KVL equation. E1 value is given as 100. So 100 is equal to, let us have I of t, the current flowing through this. Okay, I of t into R plus L into di by dt. Okay, so 100 is equal to, R value is given as 50, L value is 0.20. So 50 I of t plus L value is 0.2 into di by dt. Clear? So this is the first step. Correct? This, as I said earlier, this is the first step. What is the second step? We have to take Laplace transform of the above equation. Correct? Taking Laplace transform, we'll get 100 by S is equal to 50 into I of S plus 0.2 S into I of S plus not plus, minus I of 0 minus or 0 plus or simply I of 0. All are same notation because in inductor I of 0 minus is equal to I of 0 plus. That is current before closing the switch is equal to after closing the switch. Clear? So it can be any notation in the textbooks. Okay, so as per the problem, it is given as the switch is closed on position at time t equal to 0. Correct? So this value will be 0 initially, okay, for the first switch. So what are the left out? You have to write 100 by s is equal to 50 IFS plus 0.2 s into IFS. Correct? We'll take IFS as common. Here IFS is common. So I will get 50 plus 0.2 s. Correct? 100 by s. Now I need IFS. So multiplication will come here as division, correct? So 100 by s multiplied by 50 plus 0.2 s. So we have to keep one thing in mind. It should be whatever you are taking now should be s plus a format. So whatever the coefficient of s should be taken out. Here the coefficient of s is 0.2. So if you take it outside, 100 divided by 0.2 multiplied by s into 50 by 0.2 divided by plus s. Clear? So now 100 by 0.2 is equal to 1000 by 2. So we'll get this as 500 divided by s multiplied by 50 by 0.2 is 250 plus s. This is where I of s. Okay. After we get IFS, what is the third step? We have to go for partial fraction. Now we have two distinct root which can be written as now a by s, correct? This is step 3. Okay, so plus b divided by s plus 250. So our aim is to find out a value and b value. So a value, how will you find out a value? A is equal to its root s into I of s, correct, at s is equal to 0. So s multiplied by 500 divided by s into s plus 250 at s is equal to 0. So s gets cancelled. If you substitute s value as 0, we will get 500 divided by 250, which can be simplified as a is equal to 2. So a is equal to 2. Then similarly b value. B is equal to now its root, correct? What is the denominator? S plus 250 multiplied by IFS. Usually we will put it as IFS at s is equal to minus 250. Okay. Which I can write this as s plus 250. IFS is 500 divided by s into s plus 250. Its root s minus 250. So both gets cancelled. We'll get this as 500. If you substitute s value is here minus 250, I'll get this as minus 2. So b value is equal to minus 2. So I substitute IFS is 2 divided by s minus 2 divided by b value is minus 2, hence it is s plus 250. So as I said earlier, what is the fourth step? We have to find out inverse Laplace transform, correct? Inverse Laplace transform. If you take inverse Laplace transform, I of t is equal to, it is 2 by s. I'm sorry, it is 2 by s, correct? So 2 minus 2, it is Laplace transform of 1 divided by s plus a. We know it is e power of minus 80, correct? Inverse Laplace transform, correct? Inverse Laplace transform of inverse Laplace transform of 1 divided by e power minus 80, correct? So you'll get e power of minus 250 into t, which can be written as 2 into 1 minus e power of minus 250t. Clear? So the question is, actually we have to find out voltage across inductor also, correct? So here itself you will find out voltage across the inductor is L into di by dt. L value in this problem is given as 0.2 Henry, correct? It is 0.2, correct? So 0.2 multiplied by 2. So I'll take this d by dt of 1 minus e power of minus 250t. Okay, if I take the differentiation of this constant becomes 0, so the remaining is 2 into 0.2, it is 0.4, correct, multiplied by 1 minus, and then differentiating this minus 250, okay, in t power of minus 250t. Okay, so minus into minus plus 250 into 4, 100, correct, we'll get 100 e power of minus 250t. This is VL, voltage across the inductor. Okay, now the transient of in the first switch is over. Now the switch is moved to the second position at 1 millisecond, correct? So that time, what is the current in the first circuit is acting as a initial current for the second circuit, correct? So we have to find out at t is equal to 1 millisecond, what is the current? I of t is equal to 2 1 minus of e power of minus 250t. If you substitute this, 2 into 1 minus e power of minus 250 into 1 into 10 power minus 3, correct? So many of you will have doubt how to put this one. So I first enter this value in the calculator, correct? See, okay, e, hope it is visible, correct, shift e, correct, e power minus 250 into 1 into 10 power minus 3. How you put this one? See here, 1, correct, put exponential minus 3. Okay, so you'll get one answer 0.77. So 1 minus answer multiplied by 2 will get 0.442. I'll take only 2 decimal place. Okay, so 0.44 amps. This is the current at t is equal to 1 millisecond. Okay, now see here, the switch is moved to position 2. Now the E2 is connected. E2 value is 50 volt, the same R and L value. R value is 50, L value is 0.2 Henry. So I just replace 100 by 50, the same equation with again the same 4 steps are to be followed now, correct? அங்கே முன்னாடி ஃபஸ்ட் சர்க்யூட்க்கு என்ன போடுமோ அதே ப்ரொசீஜர் தான் போடணும். பட் த திங் இஸ், இனிஷியல் கரண்ட் வந்து ஃபஸ்ட்டில் வரும்போது என்ன 1 மில்லிசெகண்டில் என்ன கரண்ட்டோ தட் இஸ் டேக்கன் அஸ் இனிஷியல் கரண்ட்டு, கரெக்ட்? அதை மட்டும் ஞாபகம் வச்சுக்கணும். இந்த டைப் ஆஃப் ப்ராப்ளம் இஸ் வெரி வெரி இம்பார்ட்டண்ட். ஸோ ஆஸ் ஐ ஆல்ரெடி டோல்ட், instead of 100 we'll get now only 50, correct? So 50 is equal to I of t into R plus L into di by dt. So லாஸ்ட்டில் என்ன பார்த்தோமோ அதே தான், 100 பதில் 50 போடணும் இங்கே. ஓகே, nothing else different here. I of t, R value is 50 plus 0.2 into di by dt. L value is 0.2. So this is step 1, correct? Writing the KVL equation. What is step 2? Taking Laplace transform, we'll get for constant 50 by s, correct, is equal to 50 into I of s plus 0.2 s I of s minus I of 0 minus or I of 0, whatever we can put it. Okay, so interesting thing is, இந்த ஃபஸ்ட்டு சர்க்யூட்டில் வந்து இந்த வேல்யூ 0ன்னு எடுத்திருக்கும். இப்போ செகண்டுக்கு மூவ் ஆகும்போது இந்த I of 0 மைனஸ் இங்கே 0வாக இருக்காது, கரெக்ட்? அதனோட வேல்யூ நம்ம ப்ரீவியஸாக கண்டுபிடிச்சிருக்கோம். இட்ஸ் வேல்யூ இஸ் 0.44. தட் இஸ் டு பி சப்ஸ்டியூட்டட் ஹியர். ஓகே, ஸோ நவ் 50 by s is equal to 50 I of s plus, I'll take this is 0.2 s into I of s minus 0.2 into what is I of 0 minus s. The previously we have founded this as position 1ல இருக்கும்போது we have founded this as 0.44, correct? That is to be included here. Okay, ரொம்ப சிம்பிள், அது மட்டும்தான் இங்கே வரும், வேறு எந்த சேஞ்சஸுமே இருக்காது. ஸோ நான் ஆஸ் யூஷுவல் 50 by s, this minus we'll get this as 0.88, correct, is equal to 50 IFS plus 0.2 S IFS. Okay, taking this as common and taking LCM here, 0.88 S is equal to, divided by S is equal to IFS 50 plus 0.2 S. Okay, and then I need only IFS, keep IFS this side and remaining thing on the another side, 50 plus 0.88 S divided by S into 50 plus 0.2 S, correct. As I already told, we should have the component here S plus A format. So S க்கு பக்கத்தில் எது இருந்தாலும் என்ன பண்ணணும், வெளியே எடுத்துருவோம். ஸோ வெளியே எடுத்தால் என்ன கிடைக்கும் அப்படின்னா 50 plus 0.88 S divided by 0.2 S. So 50 by 0.2, correct, plus S. So this point is to be divided by the entire thing. 50 by 0.2 பார்த்தீங்கன்னா we'll get this as 500 by 2, so we'll get 250, correct. 250 plus we'll get again this as 0.44 S, see here, divided by S into S plus 50 by 0.2 is again 250. So this format. So regardless of the numerator, we have to see only the denominator. Denominator we have distinct root, again the same thing. Once we found out this IFS value, correct, IFS value, what we have to do, this is our step 3, correct. Step 3, take partial fraction, correct. So we'll get IFS as 2 distinct root as A by S plus B by S plus 250. ஓகே, ஸோ எந்த சேஞ்சஸுமே இல்லை, அதே மாதிரி தான் பார்ஷியல் ஃப்ராக்ஷன் எடுக்கணும். நியூமரேட்டர் என்னவாக இருந்தாலும் அதை பற்றி கவலைப்பட வேண்டாம், இந்த மாதிரி போட்டுக்கோங்க டிஸ்டிங்க்ட் ரூட் இருக்கிறதுனால. ஸோ அகைன் ஆஸ் யூஷுவல் ஏ வேல்யூ டு ஃபைண்ட் அவுட் ஏ வேல்யூ எஸ், அதனுடைய டினாமினேட்டர் மல்டிப்ளைட் பை IFS அட் இட்ஸ் ரூட் இஸ் S is equal to 0, கிளியர். ஸோ S இன்ட்டு, ஸோ இந்த நியூமரேட்டரோட சேர்த்து வர எல்லாத்தையுமே போட்டுப்போம். இப்போ 250 ப்ளஸ் 0.44 S divided by S into S plus 250, correct, at S is equal to 0. So S cancel ஆகிடும், S ஓட வேல்யூ 0ன்னு சப்ஸ்டியூட் பண்ணுவேன்னா இது கேன்சல் ஆகிடும், இது கேன்சல் ஆகிடும். தென் 250 divided by 250, its value is 1. So A value is equal to 1. Okay, A value will be 1. Similarly, B is equal to B, the denominator of B is S plus 250. So அதை எடுத்துக்கணும், multiplied by what is IFS value, that is to be taken its root at S is equal to minus 250. Okay, see here, S plus 250 into IFS value at S is equal to minus 250. 250 get cancelled. So if I substitute this 250 plus 0.44 S oda value minus 250, correct, divided by, again this S value is minus 250. So if you simplify this, we'll get 250 minus 110 divided by minus 250, correct. Further simplifying this, we'll get this as B value as minus 0.56. Okay, so A and B value is already found out. So now IFS is equal to, substituting A value is 1, so 1 divided by S minus 0.56 divided by S plus 250, correct. So A and B value is to be substituted simply, nothing else. Then step 4, what is the step 4? Taking inverse Laplace transform. What is inverse Laplace transform? I of t is equal to 1 minus 0.56 e power of minus 250t. Okay, inverse Laplace transform of 1 divided by S plus A, we know the formula is equal to e power of minus 80. Okay, so that is substituted here. Now this is where I value. Okay, so if they ask voltage across the inductor means, so L into di by dt, they asked voltage across the inductor in both the intervals. So this also we have to find out, means L value is 20, correct. L value is, it is here, just check, L point 2, correct? 0.2 into d by dt of 1 minus 0.56 e power of minus 250 into t, correct? So 0.2 differentiating this one has become 0, the left out is minus 0.6 and then minus 250 into e power of minus 250 t. So I'll get VL this as 28 e power of minus 250 t. Okay, so in both the cases, whether it is relaxed or initial current, okay, so we'll get this as voltage and current waveform as this format. This is I of t and this is V of t. Okay, if it is having some initial value means instead of 0, no, it will start it, instead of starting at 0, it will start from 0.44 amps. Okay, this is a common waveform for all type of RL transients. Okay, thank you all for watching this.